Okay, so this week's Fix It Friday probably seems quite easy. It's actually quite a GCSE level question. We're talking about 3 observations you could make when sodium is added to water, and we should be well aware of the formula equation for this, which is that we're going to produce sodium hydroxide and hydrogen gas. And at A-level, we're also expected to know that, for example, calcium and the more reactive elements at the bottom of group 2 will also react with cold water to produce hydrogen gas. So let's talk about observations, because it seems easy, but lots of students get lots of things wrong. So fizzing is an obvious observation because we're producing hydrogen gas. Effervescing is a repeat, and this happens a lot with gases. So we say, oh, it fizzes, it bubbles, it effervesces, a gas given off. That's all the same thing. In fact, I'm going to talk in a minute about the whole gas given off situation. But let's take this in order. So fizzes gets a mark, effervesces would probably be ignored. It is a dangerous thing to say in any situation when you're trying to explain or describe something, and in this case there are 2 things, the metal and the water, so we want to avoid saying it. Reacts, correct, it does react. However, reacting isn't an observation because you can't see atoms losing electrons, gaining electrons, forming new bonds, breaking bonds. That is not something you can visibly see, so observations need to be things that you can definitely observe with the naked eye, like bubbles, colour changes, that kind of thing. So reacting is true, but would be ignored and wouldn't get any marks, and dissolving is not true because we've just said it is a chemical reaction. It is not dissolving, so we're not making a solution of sodium, we're making a solution of sodium hydroxide. So instead of saying dissolving, what we want to say is that the metal disappears. This question is also very common in A-level with, for example, the addition of magnesium to acid or a carbonate to an acid as well. Same idea, the solid reactant disappears during the reaction. Disappears may sound like it's not a very technical term, but that is literally what you observe. You observe the metal getting smaller, shrinking, and it's not there anymore. Okay, let's look at the next phrase. Gas is given off. No, at best ignored because it doesn't add anything. So the reason for that is that actually, if you think about it, you can't see gases. Okay, unless they're coloured, which is really, really rare. So if you think about this, the best example would be to think about calcium carbonate or any carbonate that decomposes when you heat it. So you put a solid in a test tube or a boiling tube, you heat it and it gives off carbon dioxide gas. Now you can tell that because you can weigh the container, but you can't see it happening really. Occasionally the solid might move a little bit, but you can't really see the carbon dioxide coming out of the tube because there's no liquid there, so there's no bubbles being made. So another way, just think about when someone's talking, you can't see the gas coming out of their mouth. Okay, the last bit, everybody learns their flame tests, both at GCSE and at A-level, and we want to get some flame colours in at every opportunity. However, there is some language in this question which deliberately says that it's a small piece of sodium and a large container of water. I don't know if you've noticed that that's how your teacher would normally demonstrate it, with a great big kind of trough of water and the sodium sits on the top and moves around and it doesn't catch fire. And actually the reason that we use a large amount of water is actually for the safety of the reaction. It helps to cool the reaction down and absorb the heat given off, specifically so that it doesn't turn into a massive uncontrollable fireball. And so therefore you're not going to get a yellow flame with just a little bit of sodium in a lot of water. If you, I don't know, put some sodium on a teaspoon and added some water to it, I don't recommend it. You might get a little bit of flame going on there. but no, only potassium, and of course lower down, is going to get hot enough to burn that hydrogen, and potassium would give you a lilac flame, as I'm sure you know. So what else can we say? We've got our fizzing, we've got our metal disappears. We can say moving on the surface for group 1, and the moving is due to the gas being given off, so pushing it around on the surface is a nod to the low density of group 1 metals. And other than that, we can also say for sodium that it melts into a ball. So sodium will do this, lithium will not do it because it doesn't get hot enough to melt. Potassium will do it, although you may not notice it because you're too busy looking at it catching fire with a lilac flame. Group 2 metals will not do this, so they will not float. They will move around a little bit because of the bubbles given off, and they will not melt into a ball either because they won't have enough heat energy to do that, and also group 2 have higher melting points.